Let's look at how we can apply the normal distribution by using our data involving the ages at which US presidents were inaugurated. So the first thing you want to do is make sure you have the pres data in list 1. So for the purposes of this lesson, it's actually going to help if we have the data in order. So right now, if you look at the data in list 1, again, George Washington was inaugurated at age 57. So notice he's first. So these are in order of presidency, not in order of age. So to do the analysis that we're going to do here in question number 2, it's best to put these in order. So in order to do that, go to the home screen. And again, on the handout, I listed the sequence of buttons that you should press in order to use the sort command. I'm going to step through it with you. So on the calculator, first you want to press the second button, and then press the stat button. That will access the list options. You can see it says list above the stat button. These are all of the different list options. You want to go to the OPS menu option. That stands for operations. It's option number 1, sort A. That means sort ascending. That's the option that you want. So with that highlighted, we're going to press enter. And we want to sort ascending list 1. So to get list 1 in there, you have to press the second button and then the number 1. So we can close our parentheses and press enter. And now the data are sorted ascending by least age to greatest age. So if I press stat and enter, now the youngest president was actually Teddy Roosevelt. He was inaugurated at age 42. So here is John F. Kennedy, 43. Now we have them in numeric order. So we'll go back to the home screen. Back to the handout then. So what percentage of US presidents are 48 years old or less when inaugurated? So since the ages of presidents at inauguration, since these are approximately normal, that's a really important idea. These data don't follow an exactly normal distribution. They follow an approximately normal distribution. We know from our last lesson that the mean is about spot on at 55 years. The standard deviation is about 6.6 years. So we can write that distribution then by writing approximately n for your shape, the normal shape, a mean of 55, and then we put a comma and the standard deviation of 6.6. We have the shape, the center, and the spread. So we've completely described our distribution. So we can also use then the standard normal distribution as a mathematical model to answer our question. So our original data are normal with a mean of 55 and a standard deviation of 6.6, but the standard normal distribution, by standard, we mean that we are using z-scores. And we know that if we're using z-scores, the normal distribution is going to have a mean of 0. Z-scores have a mean of 0. It's going to have a standard deviation of 1. Z-scores have a standard deviation of 1. And we know that this is then a density function. The area under the standard normal distribution, the area is 1. So we can use this as a mathematical model to answer our question. So again, the question was, what percentage of presidents are 48 years old or less when they're inaugurated? Well, if we're going to use the standard normal model, we should start by converting 48 years into a z-score. So z-scores are found by taking the observation minus the mean and dividing by the standard deviation. So in this case, the observation is the 48. We're going to subtract our mean of 55 and divide by our standard deviation of 6.6. Again, we got those from the model. So I typically round z-scores to 2 decimal places. So here, if you're going to do this as one calculation, use parentheses then around your numerator. 48 minus 55, that's the observation minus the mean. Divide by the standard deviation of 6.6. So that gives us a z-score of about negative 1.06. If I round that to 2 decimal places. So the best way to show your work is to draw and label a picture of the model. Well, this model, we know that the shape is the bell curve. So I will draw my bell curve. To be a density function, I need to be using the standard normal distribution. So my mean should be 0 since I'm using z-scores. My standard deviation is 1. So I'll approximate 1 standard deviation out from the mean. There's my distance for 1 standard deviation out from the mean. So again, you don't need to take the time to label 1 and 2 standard deviations above and below the mean. All you're communicating when you draw this picture is that you are using z-scores. I'm using a mean of 0, and z-scores have a standard deviation of 1. I'm going to use a standard deviation of 1. So now what I'm interested in, though, is the percentage of presidents that are 48 years old or less. So that less is very important because it tells me the direction in which I want to shade in order to find and represent the area that I'm interested in this question. So notice at 48 years of age, that's a z-score of negative 1.06. So if this is 1 standard deviation above the mean, here's about 1 standard deviation below the mean, and I'm ever so slightly below that, so I'm just going to put in my boundary as negative 1.06. So, and I'm interested in being this old or less. So that tells me that I want to shade to the left. And that shaded region here communicates the area that we're going to find. That area corresponds to a percentage of this distribution, and that's what I'm trying to find, the percentage of presidents that are 48 years old or less. So to find that percentage, I can use the shade norm command. Now, the shade norm command, though, requires a lower boundary and an upper boundary. So notice I've got my upper boundary on the right side of negative 1.06. I don't have a lower boundary. So when you don't have a lower boundary, when you want to account for the entire distribution below the negative 1.06, the lower boundary that we are going to use is a z-score of negative 10. So using a lower boundary of negative 10 and an upper boundary of negative 1.06, that will give me my shaded area using the shade norm command. So this is the lower boundary, and this would be the upper one. So let's put it in, and we'll be able to answer our question. So to the calculator. So you need to have the correct window set. So this is the window that we have been using in order to use the shade norm command. -3 to +3. I suggest a scale, an x scale of 1, so that you can see increments of 1 standard deviation along the horizontal axis. -0.2 for your y min, 0.4 for the y max, and 0.1 for the y scale. So with that window set, I'm going to go to Second, Variables, the vars button. I need the Draw menu option. There's the shade norm command, so I'm going to press enter. Then the lower boundary that we've specified is -10. The upper boundary that we want is the z-score we calculated. That's -1.06. And then we can highlight draw and press enter. And we'll see the shaded region on the screen, and it will give us the area. And in fact, that area is the percentage that we've been looking for. So it's about 14.5%. So our model suggests, and you should label then your shaded area 0.145 approximately. That shaded area is 0.145. So that corresponds to about 14.5%. So that, according to our model, is the answer to the question, what percentage of U.S. presidents are 48 years old or less when they're inaugurated? So what I wanted you to realize is this is the answer that the model predicts, but because we took the time to sort our data, we can actually go see how accurate this prediction was for our model. So let's go look how many presidents were 48 years old or less when they were inaugurated. So to do this, I'm going to leave the drawing screen here. So I'm going to press second mode. So before I forget to do this, also, after you've made a drawing, if you intend to make another drawing, the next thing you should do, before you do anything else, don't forget to do this, is clear your drawing. Second button, Program button, that takes you to the drawing options. You can see the DRAW above the Program button. Clear draw is the command that we want, so you can just press enter once to bring the command to the home screen. Press enter a second time to actually execute the command. Clear the drawing screen so we're ready to do our next calculation. Again, the reason though for coming back to the calculator was to go look at the data. If you press stat and enter, because we've sorted the data, we can actually calculate, we can count how many presidents were 48 years old or less when they were inaugurated. So the youngest was Teddy Roosevelt at 42, so let's count. There's 1, 2, 3, 4, 5, 6, 7. Let's keep going. Let's see, there are 7. 7 out of 45 were 48 years old or less when they were inaugurated as president. So the actual answer is 7 out of 45. So let's see what 7 out of 45 is. I know we're pretty close. So going back to the home screen, 7 divided by 45, the actual percentage by using the data is about 15.6%. So again, what I want you to realize is our model predicts 14.5%. The actual value, according to the data, is 15.6%. They're not exactly the same, but that's not the idea of a mathematical model. The model is meant to be an approximation to reality. It's not a perfect fit, it's an approximation. And that's the idea behind using a mathematical model. So in the next video, we're going to look at the percentage of presidents that are 59, that are over 59 when they're inaugurated. We'll do questions 3 and 4 and 5 next to give you a little bit more practice with the shade norm command and with showing your work.